There is a new AI buzzword every few weeks now. Prompt engineering, context engineering, harness engineering, agentic workflow design, loop engineering. The cycle is almost musical at this point. Someone coins a term, someone else writes a $49 course, then a LinkedIn influencer becomes a certified prompt architect, and just as you finish the course, the whole thing is obsolete. You could literally watch the half-life of an AI skill in real time. Prompt engineering went from future of work to that's it in about 18 months. And the pace is only accelerating. Entire paradigms are living and dying inside a single product cycle now. If you try to actually keep up, truly keep up, it would be your full-time job, which is a little ironic for the field that's supposed to be automating jobs. But here's the thing. Instead of just laughing at the bus treadmill, it's actually worth slowing down and understanding why each one showed up. Each term wasn't random. Each one was a real response to a real limitation. And if you follow the chain, you will see exactly why we ended up where we are and why the next step matters more than all of them. It all started with the prompt engineering. This was the first era. You had this incredibly powerful model in front of you, and the only interface was a text box. So naturally, people obsessed over what they typed into that box. Word you request this way, not that way. And these magic phrases, structure is like a recipe. The model was mesmerizing. It could write poetry, explain quantum physics, draft a legal memo, and everyone was just admiring how smart it was. But the admiration did not pay the bills. Pretty soon, people didn't just want the model to be impressive, they wanted it to be useful. Actually do something for them. Generate the report, analyze the data, build the feature, and that's when the problem showed up. The model was incredibly capable, but it knew almost nothing about you. Your company, your code base, your preferences, your history. You could type the perfect prompt and still get something generic because the model had no idea who you were and what you needed. And so the next wave arrived, context engineering. The idea was simple in theory, brutal in practice. Feed the model enough about the user, the project, the environment, everything, so the output is actually tailored and useful. But here's the catch. Models have a context window. There is only so much information you can shove in before the model gets overwhelmed and starts ignoring half of it. So now the skill isn't just writing prompts, it is deciding what the model needs to know and what to leave out, curating information, managing attention. Suddenly, everyone's building retrieval systems, chunking strategies, memory layers. The prompt is almost secondary. The real game is what goes around it. But even with great context, the model is still reactive. It sits there, you ask a question, it gives you an answer, you ask another, it answers again. Every interaction starts with you. The model never reaches out on its own. This never checks your calendar, drafts an email, reads a document, and acts, unless you explicitly tell it to. And that's the gap agentic engineering was born to close. The idea, put the model in a harness, give it tools, access to files, emails, calendars, databases, APIs, give it the ability to take actions, not just answer questions. Now, the model isn't waiting for you. It can reach out, pull information, write a document, send an update, trigger another process. It goes from very smart notepad to something that actually does things. This is where a lot of teams are right now. And it's genuinely powerful. Agents writing code, managing workflows, coordinating with other agents, it feels like the future. But there is a next step. And this one is different. It is what happens when you stop thinking about individual tasks and start thinking about systems that run themselves. Instead of prompting an agent every time something needs to happen, you design a loop. The loop finds the work, it hands it off to an agent, it checks what came back, it decides what to do next, and repeats on a trigger, on a schedule, or until something is truly done. The creator of Claude Code literally said on stage, "I don't prompt Claude anymore. My job is to write loops." Google's Adi Osmani wrote the defining essay on this. The CEO of OpenClaw, the most starred new open source project on GitHub this year, tweeted 12 words that broke the AI internet. You shouldn't be prompting your coding agents anymore. You should be designing loops that prompt your agents. It's everywhere, and if you're a manager, or executive thinking about how AI fits into your work, this is the layer you need to understand because it is coming to every domain, not just software. Because here's the truth about daily life, it's mostly loops: checking email, reviewing reports, following up on projects, updating a spreadsheet, building a career. Most of what you do is repetitive. Small cycles or big ones over and over. And loop engineering is about handing these cycles to a system that doesn't get tired, doesn't forget, and doesn't drop the thread. And this is all great, but most people, and I mean most, will miss the single most important part of loop engineering, and that part is knowing when to stop. Let me give you a real example. I'm currently using an AI agent to help develop software for a robot. The robot runs locally, no cloud, no internet dependency, all the intelligence is on board. The agent can go ahead and write code for me. Thousands of lines, complex logic. It can be genuinely useful. But here's the thing, I cannot just accept everything it gives me because sometimes the code doesn't even compile. That's the easy case, right? The system can catch that automatically, feed the error back, let the agent try again. Fine. But sometimes the code compiles, it runs, the tests pass, and it's still wrong. How? The agent writes a unit test that looks like it's checking a critical workflow, but it really is just checking whether a variable is equal to itself. It passes every time, it proves nothing, and looks bulletproof at a glance. This is what makes the stop condition problem so hard. The agent isn't malicious, it's not trying to deceive you, it's just dumb in a very specific way. It has PhD level knowledge about 9 things and a blind spot about the 10th. And you never know which one is the 10th. So what do? You make the stop condition stricter. Level 1, does the code complete? Basic, but necessary. Level 2, do the test pass? Okay, better. But we just saw the problem. The agent can write a test that passes while testing nothing. Level 3, fire up a simulator. Give the robot a task. Does it actually do what it's supposed to do? Now we're getting somewhere. But a simulator is not reality. Simulating physics is hard. Simulating all the edge cases the real world throws at you is almost impossible. So level 4, run it on the actual hardware, the real robot in real environment. This is where you finally know, but it requires infrastructure, setup time, it's expensive, it's slow. Every level up gives you more confidence, but every level up also costs more to build. And here's the uncomfortable truth. You can never fully automate the stop condition if you care about the quality of the output. Not yet. At some level, a human still needs to verify that the verification itself is correct. That is the test, that the test is actually testing the right thing, and the simulator covers the right scenarios. People can tell you, just ask the agent to write the test too. And you can, but then who verifies the test? You are in the loop within the loop. Someone has to break the chain. Here's what the research says. Someone actually ran 47 real AI agent loops to test this. They found that a loop with clear test-gated stop condition ran 31% faster and 7% cheaper than one with vague until it works stopping condition. That's a massive difference. But here's a catch. The test-gated loop only works if the tests are actually good. If the stop condition looks satisfied but the verification is hollow, you just automated your way to confident mistakes. The stop condition isn't the step in the process. It is the process. It is the thing that determines whether your agent system produces garbage or something you can actually use. So where does this leave us if you're thinking about AI in your organization? Here's the thing more people need to hear. The leverage is smooth. It's no longer about writing the perfect prompt, it's about designing the loop. And the most important part of the loop, the part nobody's courses teaches you because it's genuinely hard, is defining what done actually means. What does success look like for your use case? How would you programmatically, measurably, not just by gut feeling, that the agent got it right? And is that verification method something you could trust, or could it be gamed by a confident system that doesn't actually know it's wrong? These are the questions that separate teams that get real value from AI from teams that generate a lot of impressive looking output they can't actually use. So start there, the next buzzword will take care of itself. If you're working through how to apply agentic workflows in your organization, I would love to hear where you're seeing the biggest gaps. Drop a comment or reach out. I'm always talking to people who are actually deploying this stuff. And if you want more breakdowns like this on the tools and concepts that matter for builders and decision makers, subscribe to the Build Robots newsletter at buildrobots.substack.com. I publish there every week. See you on the next one.